This tutorial shows you how to calculate the minimum required sample size for a two-way ANOVA using R. To do this, we need the pwrss package, which can be installed using the install.packages function and loaded with the library function. Note, the name of the package must only be enclosed in quotation marks when using the install.packages function. Start with the pwrss.f.ancova function. Don't be misled by the name of the function. It can be used to calculate various analyses of variance, including ANOVA and ANOVA. The first input parameter for a two-way ANOVA is the effect size Eta². Alternatively, F² can be used, depending on what is reported in existing studies. Both measures can be converted into one another. For reference, see the formulas from Cohen 88, pages 281 and 284 respectively. If no comparative study exists, you can use research field-specific thresholds. If those are also non-existent, the conventions for the social and behavioral science may be used. They are not for F² though, only for F, and are 0.1, 0.25 and 0.4 for small, medium and large effects, and taken from Cohen 92, a power primer, page 157. In this example, I select an F value of 0.25 and define it in a separate variable. The second input parameter is the number of levels for each factor, which is set using the n.levels parameter. For example, if the first factor has 3 levels and the second factor has 5 levels, this is entered as n.levels equals c and within parentheses 3, 5. Spoiler, at the end of the calculation we will obtain the minimum sample size needed for the main effects of each factor and for the interaction. Typically, the interaction effect is the most interesting and provides the critical sample size required. The third input parameter is the alpha error probability, i.e. the likelihood of committing a type 1 error, rejecting the null hypothesis when it is true. Common values are 0.05 or 0.01. Values above 0.05 should be avoided, as they increase the risk of detecting an effect that does not actually exist. The fourth input parameter is power and equals 1 minus the beta error probability, i.e. the probability of committing a type 2 error, failing to reject the null hypothesis when there is actually an effect. Higher power values are preferred to minimize the beta error. By default, a power of 0.95 is used, though in some disciplines, slightly lower values like 0.8 are acceptable. However, values below 0.95 often require justification. Finally, the minimum required sample size for the specified input parameters can be calculated. For the interaction effect, A multiplied with B, we see a minimum sample size of 372 when the entered parameters are considered. To observe only the main effects, fewer observations are required. The fewer levels a factor has, the smaller the sample size needed. In most cases, the interaction effect is the primary focus of a two-way ANOVA, making this number the critical value. As a rule of thumb, a smaller effect size and a larger power require more observations than the other way around.